Gosh, I wish I didn't have to use this light. Light's too mainstream. Wish I had something else to use instead. You totally can. You can make a lava lamp. Who are you? What are you doing in my house? Are you a Jehovah's Witness? Damn, you guys are getting good. What? No, of course not. I'm your new chemistry guy. Oh wow, so you're gonna help me with the lava lamp and help me pass chemistry too? Of course. But first we have to understand how a lava lamp works. Alright, so what we're gonna need to make our lava lamp is a bottle of water to make the lamp, Alka-Seltzer, food coloring, and any type of cooking oil. A lava lamp's functions are mainly due to density and polarity. Density basically means how compact something is, how much something fits in a certain amount of space. Density equals mass over volume. Alright, it wouldn't be chemistry without some difficult math problems to solve, so let's find the density of my water bottle. Alright, step 1. Find the mass and volume of the water in my water bottle. So the mass is 11.2 grams, right? The volume equals the bottle with 2 centimeter sides. Volume of the bottle is length of the side cubed. The volume is 2 centimeters. Cube that, you get 8 centimeters cubed. Alright, now step 2. Can you follow along? Plug your variables into the density formula. Density, as we know, is mass over volume. The density is 11.2 grams over 8 centimeters cubed. So the density, after doing some difficult division, would be 1.4 grams over centimeters cubed. If you measure an equal volume of oil and water, you'll find that the water is heavier than the same amount of oil. This is because water molecules are packed more tightly together and a cup of water actually has more mass than a cup of oil. Because water is more dense than oil, it will sink to the bottom when the two are put in the same container. Even though they have different densities, oil and water would eventually mix together if it weren't for polarity. Water molecules are polar because they have a lopsided electrical charge that attracts other atoms. The end of the molecule with the two hydrogen atoms is positively charged. The other end with the oxygen is negatively charged. Just like in a magnet where opposites attract, the positive end of the water molecule would connect with the negative end of the polar molecules. Oil molecules, however, are nonpolar. They do not have a positive or a negative charge, so they are not attracted to the water molecules at all. This is why oil and water don't mix. In our homemade lava lamp, we will use Alka-Seltzer to power the lamp. The Alka-Seltzer reacts with the water to produce carbon dioxide gas bubbles. These stick to the water droplets. The water and gas combination is less dense than the oil, as we learned, so they rise to the top of the flask. At the top, the gas bubbles pop and escape into the air, allowing the dense water to sink back to the bottom again. Now time for the experiment. I don't know, the article I read said do it in moderation. Moderation's for cowards. Right now we just gotta stir a bit. Make sure Alka-Seltzer tablets. Oh, look at that, it works. Oh, look at that. It works. This is why chemistry is awesome. See, yeah. Like, you all learned something today. You can, like, make your own lava.